chi-squared goodness of fit hypothesis tests where the table of O and E values is given. So just to summarize the basic method, you start off with a random sample and you test the data from this random sample against a probability distribution. The O values in the table are from your random sample. The E values are typically calculated using the probability distribution, but for the examples in this video you will get a complete table with every value in there. The one thing you need to watch out for are E values which are less than 5. From the E values and the O values there, you calculate your test statistic. This formula is on page 14 in the AQA formula book, and then from there you go to the chi-square distribution. To get the critical value, you need to know the number of degrees of freedom that you're working with. It's always a one-tailed test. The critical region is always on the right hand side, the upper tail, and then you can either accept H0 or you can reject H0. So our hypothesis test will be carried out using one of these distributions, either something that's continuous or something that's discrete. Example 1. So we have a complete table, all of the O values and E values on here, all of the E values are at least 5, so no issues there. 5% significance level. There are 5 classes. Do not include the total column there when you're looking at the classes. So H0 and H1. 5 minus 1, 4 degrees of freedom. 5% significance level. So going to the chi-squared probability tables. So 5% here, 95% here. So we're in this column. 4 degrees of freedom. Critical value 9.488. So here's the critical value. We now just need to work out our test statistic. Using the formula and all the values in the table, TS is 4.27, and we can see that 4.27 here is less than 9.488, so we're going to accept H0 and then our conclusion. Example 2, a 5% significance level. We're using a normal distribution this time with a mean of 65 and a standard deviation of 8. So we're not just testing the distribution, we're also testing these parameter values as well. We have our table with O and E values, and we can see that the E value here is less than 5, so is this one. So these classes will need to be combined, giving us a single class for less than 60, and these two need to be combined, giving us a single class here more than 70. Our new table, there are 3 classes here, 3 minus 1, 2 degrees of freedom, and our H0 and H1 mentions both the distribution, so the data follows a normal distribution, and the parameters with mean 65 and standard deviation 8. So we're testing both things here, both the distribution and the mean and standard deviation. Our test statistic, 4.53. A 5% significance level, 2 degrees of freedom. So 5%, 95%, 2 degrees of freedom, 5.991 for the critical value. So we accept H0. 4.53 is less than 5.991. And our conclusion. example 3, 1% significance level, and we want to see if our data will fit a binomial distribution. The e-values here are both less than 5, but if you add them together, it gives you an e-value that's at least 5. So we need to combine these categories together to make a new one called 4 or more. So here's our new table. The new class that we created is here. So now there are 5 classes, excluding the one at the end. We're not including this, it's not part of the values we're looking at. There's 5 classes, so 4 degrees of freedom. H0 and H1 give mention to the binomial distribution. Working out our test statistic using the values in the table, the O and E values, we get 16.76. Using a 1% significance level and 4 degrees of freedom. So this value here, this is 1%, this is 99%, 4 degrees of freedom, 13.277. Our critical value, 16.76 is greater than 13.277, so we're going to reject H0. And our conclusion. So as you've seen, doing a basic test where you have a table with all of the O and E values in there is straightforward. You just have to check that the E values are at least 5. If not, you combine categories together. Now for the degrees of freedom, it's always k minus 1. So k is the number of classes after you've done all your combining categories if needed. And it's k minus 1 for all of these, unless you have calculated a population parameter as a part of your working out. So for example, if you're working with a binomial distribution and you've done a calculation for the value of p, so let's say p is 0.7 in a question, and you've shown it's 0.7 by actually calculating that value, then you do k minus 2 degrees of freedom in your hypothesis test. In a Poisson distribution, the mean lambda, if you've had to work it out somewhere as a part of your solution, then you have to use k minus 2 degrees of freedom. For an exponential distribution, again, if you've worked out lambda somewhere or the mean, then k minus 2 degrees of freedom. And for a normal distribution, there are 2 parameters, and if you've worked out both of these parameters as a part of your solution, then k minus 3 degrees of freedom.